What is up, mathletes? I got a special guest here, and we're going to talk to you about how to complete the square. So, as Toby would say, don't go anywhere. All right, mathletes. So before we actually complete the square, let's see the benefits of how it's going to help us out. All right. So once we've completed the square, we're going to see a nice format just like this, right? Or something very similar. And I say nice because to solve this is going to be quite simple, right? We know to get rid of that square, we're going to take the square root of both sides. So let's go ahead and do that. But we know when we take the square root, we're going to have a plus and minus. So make sure you jot that down. All right. So we're going to take the square root of both sides to get rid of that square. All right. And so since we're left with a plus or minus, that means we have two equations, right? So in most of our answers, what you're going to see is that you're going to end up with two solutions, right? Is that always going to take place? Absolutely not, right? But we're going to see that for most cases that will happen. All right, so again, I'm just taking one of my equations is going to be x minus 2 equals the positive square root of 9, and then we're going to have x minus 2 equaling the negative square root of 9. Okay, so that's what we have once we get rid of that square. And then now we just take the square root. All right, sometimes that's going to be easy to do, sometimes it's going to take some work. All right, so we're left with x minus 2 equaling positive 3. And then over here we have x minus 2 equaling negative 3. So in this particular case, we're going to end up with two solutions. And so solving each one of these are just linear equations, so they're much easier to solve. So we get x equals 5 as one of our answers, or let's go ahead and add 2. X equals negative 1. So those are our two solutions for this case, right? So what we're going to see is completing the square is going to create this nice equation in this nice form here that's going to make it much easier for us to solve. All right, so let's go ahead, let's get our hands dirty, and let's actually complete the square from start to finish. Follow me. All right, so let's start off with this example. We could see right off the bat that if I take the square root of both sides, that doesn't help me because, right, this isn't going to simplify at all. So that does not help. If I were to subtract the 4 to both sides and set this equal to 0, I will try to factor, but I would see that this is prime. It's not factorable. So this is where completing the square really comes through. All right, so what I want, my goal, right? So let me write my goal is I want something along the lines of x plus a squared equaling some number, right? So I want it to look something like this, because once I have that square there, I know I could take the square root of both sides to get rid of that square. So how do I create this, right? And that's what I'm going to talk about. All right, so again, there's going to be a little bit of a story that I have to tell to remind you of some facts. All right, so what we're going to do in this process, what we do is we always make sure that there's a 1 right here. If there's not a 1, what you would do is you would divide every single term here by the leading coefficient. In this case, the leading coefficient is 1. But what you see here is that's not going to change anything. So make sure in your notes as you're writing this down that you always check to see if there's a 1 right here. If not, you're going to it's going to give you some issues, right? It's going to give you some problems. You're going to need a Tylenol right there by your side, which is one of our sponsors for today. I'm just kidding. All right. So what do we do now that we have that leading coefficient of 1? Well, you focus on that b term, that middle term, right? And what you're going to do is you're going to take half of it. So write that down. You always multiply it by 1/2 or divide by 2. It's the same thing. And then you square it. So actually, let me go through and let me put that in blue because that's always going to be the same. So you always take this term that's next to your x, you divide it by 2 always, and then you square it. All right. So let me simplify that. And so if I simplify that, we're gonna get 3 squared, which is 9. So this 9 is what you're gonna add to both sides, right? And there's a reason why, let me highlight this, there's a reason why I simplified it, right? Because I'm gonna show you guys a little trick, right? I can't be giving you all my secrets here. Can't be giving you all my secrets. So there's something we're gonna do with that 3. Stay tuned, right? Don't go away. We're gonna take that x squared plus 6x, and we said we're gonna add 9 to both sides. So again, this is an equation. You have to keep things balanced. So in this case, we're gonna add 9 to both sides. All right, so we're adding 9 to both sides. All right, and why do we do that? Well, if you notice, right, if I were to try to factor this, now this is going to factor perfectly, because this is now a perfect square trinomial. Meaning when you factor it, you're going to get 2 factors that are exactly the same, and that's why you're going to be able to write it as a plus something squared, or x plus something squared, or x minus something squared. All right, you're going to see that happen right now. So I could factor this. If I were to factor this, and right now I'm going through all the steps, right? In my next example, now that I've explained it, you're going to see that you're going to be able to jump steps, but you first have to understand. If you don't understand, then every single time I want you to write down exactly what I have here. If you do understand and you have that deep understanding, then you're going to be allowed to skip steps, but you have to have the understanding. All right, so if I were to factor this, I get an x right here, and I get an x, and then I get a plus 3, and then I get a plus 3. So those factors, if I were to multiply everything out, right, they're gonna give me this, right? And I usually give this to my students as a bonus. So here you go, right? Here's a quick little check. So if I multiply the inner, I get 3x. If I multiply the outer, I get 3x. And look at this right here, 3x plus 3x, indeed it gives me 6x. So this checks out. I have factored that correctly, all right? So please make sure you have that in your toolbox so you know how to use that, all right? Another thing, actually I'll save that last tip for in a few seconds. All right, notice how many x plus 3's do I have? Well, we have 2 of them. So I'm gonna rewrite this as x plus 3 squared equaling 13. And here's the shortcut, and it always works, even on Sunday. All right, so the shortcut is this right here. This plus 3, if I were having trouble factoring this, you shouldn't, because you could just take the square root of 9. But if you were having trouble factoring this, I could just go over here, take that number, since it's positive 3, bam, and there you go, plus 3. All right, so a little shortcut for the future, because later on you might end up with fractions, and this will save you some time. All right, now let's go ahead and solve this. So let me actually rewrite this over here, give myself some more real estate. So I end up with x plus 3 squared equals 13. Well, now I know I take the square root of both sides. So now I'm at a place that looks much easier. I'm going to apply that square root property. So I'm going to take the square root of both sides. So let me do that in red. Take the square root of this side, square root of this side. Let me add that plus and minus, right? Because we're going to get 2 answers. So we're left with x plus 3. X plus 3 equals plus or minus the square root of 13. So we end up with 2 solutions, right? So one equation we end up with is going to be x plus 3 equals negative square root of 13. And typically we would try to break down the square root of 13 and simplify that. Unfortunately, 13's prime. Well, I guess we should say it's good. It's a good thing, because you're done in terms of simplifying that. So this is one of our equations that we end up, and our other equation is x plus 3 equals positive square root of 13. And now we just isolate our x, because that's what we're solving for. So we subtract 3 from both sides. So one of our solutions is x equals negative 3 minus the square root of 13. Or, right, that's one of our solutions. Or we'll go ahead and subtract 3, and we'll get x equals negative 3 plus, because it's a positive square root of 13, the square root of 13. So now there are your two solutions right there. So again, a little recap before we try another problem is that we want to take this form that they give it to us in, and we want to rewrite it so that you have something squared equaling a number. Because once it's in this format, we could apply that square root property, which just means you take the square root of both sides, because that's how you get rid of a square. If this were a cube, which some of you are going to see later on, you would take the cube root of both sides, right, to get rid of that exponent. All right, so hopefully this is making sense. I would say the most important part of this problem is smashing that like button, because we're putting a lot of work in for you guys. All right, and then subscribing. All right, so follow me. Let's look at this next problem. All right, mathletes. So let's go ahead and let's go beast mode on this problem. All right, so this one is going to involve a lot of ideas, and it's also going to talk about, it's going to remind us what happens when we have radicals in the denominator. So we're going to talk about completing the square, but we're also going to look at other ideas that you should have looked at. If not, don't worry, I'll teach you. All right, so first things first, as I look through this, I will try to factor it, of course, and I see, oh, this is prime, I can't factor it. Or maybe you can, but I would always try to factor it first, but a lot of cases, they might be prime. So let's run through the process. We always said we want the leading coefficient to be 1. In this case, we have a 2. So let's go through here and let's divide everything by 2. So every single thing here, we're going to divide it by 2. So we get x squared plus 4x minus 25 over 2 equaling 0. And I'm just going to leave it as a fraction. All right. So just because we have a fraction, that doesn't change anything. So don't change the rules just because you have a radical or a fraction, right? You always, math is math, it stays the same, and just make sure you understand the principles of what you're learning. All right, so now I'm going to move that 25 over 2 to the other side. All right, so let me go ahead, I'm going to add 25 halves to both sides. All right, and then I'm going to have x squared plus 4x equaling 25 halves. All right, so now let's focus on that middle term, which is that 4 right there. So I know I'm going to take half of 4, right? So I'm going to take half of 4, and then I do what with that? Good, I square it. So we take half of 4, and then we square it. So you end up with 2 squared equaling 4. Now what? What do I do with that 4? Perfect. You add that to both sides. So this is, and then write this in your notes, right? Add to both sides. Add to both sides. All right, see, this one's wearing out my Apple Pencil. Got to tying that bad boy up. All right, so let's do it. Let's add that 4 to both sides. So let's go x squared plus 4x plus 4 equals 25 halves plus 4. And why not put 4 over 1? So if you want to do that, run that in the calculator, simplify it. Or let me just do it by hand real fast. Multiply top and bottom by 2 because we want the least common denominator. So this is going to give me 8 over 2. All right. So we're going to end up with 33 over 2. So let me write that down. We're left with 33 over 2. So again, 4 times 2 gives me 8 over 2. These have the same denominator. So now 8 plus 25 gives me 33 over 2. Now, I don't have to worry about factoring this. I can factor it. This one's actually really easy to factor, but using our technique that we discussed, I'm going to have x, and let me highlight this, and I'm going to take this 2 right here. Oops, that's not a highlighter. That's an imposter. I'm going to take that 2 right there, and I'm going to stick it right there, right? And this always works. Plus 2. And of course, that's squared because we're going to have 2 copies. That's the whole point of this. All right, so let me go ahead and do some math. Oh, that's not what I wanted to do. Let me grab this piece. I'm gonna make a copy for us. And I'm gonna, oops, I wanted to grab the whole thing. And I wanna move it over here, give us some more real estate. All right, how do I get rid of that square? That's right, we take the square root of both sides. We're gonna take the square root of both sides. Don't forget, we're gonna have a plus or minus. We're gonna have two equations there that we're solving for. So one equation is going to be x plus 2 equals the square root of 33 over the square root of 2. You'll see in a few minutes why I wrote it like this. So again, if you ever have a fraction inside of a radical, this is one of our properties. We're allowed to do that. Or we're going to take the same thing, x plus 2 equals negative square root of 33 over 2, square root of 2. All right, and the reason I wrote it like this is because you never want a radical in the denominator. So we're gonna have to rationalize the denominator, which means get that square root out of the denominator. That's illegal in math, right? So that's what we're doing there. All right, we're gonna subtract 2 to both sides. So we get x equals negative 2 plus the square root of 33 over the square root of 2, all right? And then for this one, or we're gonna subtract 2 as well, and you're gonna get x equals negative 2 minus the square root of 33 over the square root of 2. All right, and so off to the side here, let me just show you, remind you if you forgot, what happens when you have a radical in the denominator. So let me just focus in on this piece over here. So when you have a radical in the denominator like you do here, right? So square root of 33 over the square root of 2, what I'm going to do is I'm going to multiply both top and the bottom, numerator and denominator there, by the square root of whatever I have here, right? Because we know that the square root of a number times the square root of itself, right, is just going to give you whatever that number was. You could do it the long way and actually multiply it out, but in my opinion that's too long. It's better to understand. So on top we have 66, the square root of 66, and in the denominator you just have 2. So this right here and this right here is just going to simplify to square root of 66 over 2. And of course you would try to simplify the square root of 66, but unfortunately we cannot. All right, so we're left with our final answer here of negative 2 plus the square root of 66 over 2. That's one of our solutions, or negative 2 minus the square root of 66 over 2. All right, mathletes, so again, completing the square here has come through, and it's a process that you're gonna have to work out, right? And make sure before you move on to any component here, make sure before you get to here that you understand each step as you go through all this. Because again, what's gonna happen is people are gonna get freaked out because they look at this, they take a step back, and they're like, my goodness, that's a long process. But again, you wanna make sure you understand piece by piece, because when you have the understanding, right, it's really not hard, but it just seems overwhelming when you step back and look at it. So I don't want you memorizing it. I want you to understand, why did you do this? Why did you do that, right? So if you have questions, make sure you comment down below. Let us know what type of videos you want to see. If you want some more examples of this, let us know. We're here to help you. All right, mathletes, don't forget to like this video, subscribe, and we'll see you guys in the next video. Peace.